Good day, everyone. My name is Iris Young, and I'm with Hewlett-Packard Enterprise. I'm very glad you're joining us today for this HPLUX webinar. I must apologize there for hacking up. Excuse me. I'm coughing here, and I didn't mean to do that in your ear. I want to welcome you to our session today, and I want to make sure that you're comfortable with the environment that we're in and that we're presenting in. So we are using a tool called On24, and let's go over a few housekeeping details. First, you've got a Q&A area. You may have noticed a welcome message from myself that popped up there. That's also the space where you'll see other questions and answers that you or other attendees to today's sessions enter. And you can enter that information just below there, and we have a group on the call here that will do their best to answer everything that you ask of us. Number two, we have a copy of the material that you can download. It's a PDF version of all the material, but we've spelled out each and every one of the links, so if we're suggesting you go someplace to get more information, it's there and easy for you to do. Lastly, in case you want to get a larger view of what's going on, please, in the upper right-hand corner of the slide area, you can enlarge that to see much more clearly. And now, let's get back to why we're here today. So we're going to focus on the benefits, tools, and ways that you can go about upgrading your HPLUX environments. And we're going to hear from HP Enterprise's Dennis Parva today. He is one of our solution architects. And Dennis, I'm just going to hand everything over to you.
Thank you very much, Iris, and welcome to the webinar, everyone. So as you can see from the agenda, it's got quite a lot of information in there, a lot of different subjects, but we're not going to deep dive into all of those. So what I'm going to try to do today is to explain the options that are available to you, and then with the benefits of my experience over the last 18 years, try and explain some of the best practices and the things that I would do on a daily basis to deploy the best solutions. So we'll have a quick look at what is upgrade and update, the architecture and OS version, so you understand what you're running on your systems today, how virtualization can help, and then what options you have for platform or application migration. So you may be running the latest platform, or you may be running a platform that you've been running for many, many years that's running an older version of HPLUX. So we need to understand what you've got before we can try and move it forward. So from a terminology perspective, I'm going to use update as changing the OS version or the revision of your operating system on a server, whereas upgrade will refer to a hardware platform change. Of course, the upgrade could also incorporate an update of the operating system. So the information that we're presenting here should always be used alongside the official product documentation. So a quick look at the current range of Integrity i6 servers. So the i6 really refers to servers that include the Intel Itanium 9700 series processor. So if you remember, we've just moved from the i4 series, the 9500 Pulse and codename servers. Itanium 9700 you may already know as Kitson codename servers. We've actually doubled the amount of memory available in a single instance for the operating system. We recently released the NVMe driver for HPLUX, which allows us to deploy the P3700 I/O accelerator cards. We now support, in effect, 3 generations of processors, all within the similar type of packaging. Service card's been upgraded to support Oracle 12CR1. We now have updated open source products available within HPLUX 2017 update release. And we have OpenStack support for HPLUX, including bare metal deployment capabilities with the Ironic driver. We've got the latest drivers for and support for storage, XP and 3PAR, excuse me. And of course, we've got extended support all the way through to the end of 2025 with HPLUX on integrity servers. So you need to check the roadmap to ensure what you might see with the PA-RISC HP9000 servers. It is slightly different, and we'll come to that later in the presentation. We maintain the 100% binary compatibility through the HPLUX 2017 release. We've got some enhancements to the Smart Core for Service Guard, and of course we now have the online migration capability with VPARs as well as with Integrity Virtual Machines. So why upgrade and why update your existing platforms? Well, of course, you get the new product features, get the virtualization flexibility that may not be available in your existing platform, improved performance, of course, and supportability. So with the current platform, we've got a very, very long longevity on the platform right up until the end of December 2025. So don't forget that HPX 11IV1 and 11IV2 are now in prior version support without sustaining engineering. So the support center can still help you provide support for these applications, but there's no engineering support behind the support center. We've got some great virtualization technology, and this continues to be enhanced as we go forward. I'll be talking about some of that today. Of course, you've got the inbuilt security with HPLUX that, from my perspective, is unmatched in the marketplace, and fantastic availability provided by Service Guard clustering. And also, of course, the HPE9000 RAS features. So this is the publicly available roadmap that you can go and download from the HPLUX Server Matrix website. So as you can see here, we've got HPX 11IV3 listed for the Integrity Titanium platform right through to the end of December 25. 11IV2 and 11IV1 have recently had their end of support life extended from December 2019 to December 2021. So let's have a look at the platform architectures and the OS versions. So if you're running a PA-RISC-based server, these are known as HP9000 systems, and some of the model numbers are listed there. And all of these systems use PA-RISC binaries. Integrity servers, on the other hand, use the Titanium CPUs, also known as IA64, and they use ELF binaries. And again, here are some of the model numbers that you might be familiar with that identify some of the product families related with those, right from the Montecito range right through to the Intel 9700 series on i6. So how do we maintain this binary compatibility across these different platforms? Well, we use the ARIES translator. So this translator is built into the base OE of all the 11IV3 images that we have today. And it automatically recognizes the PA-RISC binaries if they run on an Titanium server, and translates those commands into information that can be interpreted by the Titanium CPU. So that is how we are able to run applications, operating systems, and binaries from HP9000 servers on the current range of Integrity servers by using the ARIES translator. More of that later on. So OS versions. So you need to understand which version of the OS you're running on at the moment. It is no longer supported just to deploy the patch bundles, the quality packs, to upgrade a version of the operating system. You need to run update UX, and if you run the command shown on the right hand side top of the page here, swlist and pipe to grep HPX 11i, this will return the version of operating system that you're running. And there's some examples shown on the right hand side there as well. So as you can see in the examples, we have DCOE, Data Center OE, 1131, which is 11IV3, 1603. This refers to 2016, the third month of 2016. So that's March 16. And below that, we have the latest version of the operating system, HPX 11IV3, 1705. We call that 2017 update release, but it's actually May 2017 version. So the currently supported versions are 11IV1, 11IV2, and 11IV3. Of course, HPX 11IV1 is PA Risk HP9000 version only, whereas V2 and V3 are both available for PA Risk or Itanium. And then the obsolete versions are shown below, but we do have some capability to migrate these to the latest platform, as I'll talk about later. So within the HPLUX OS, we have these operating environments. And in effect, these are bundles of software that make it easier for you to install and deploy and manage your HPLUX systems. So historically, we have the mappings on the left-hand side of the page here. Foundation OE, then layered on top of that was Enterprise OE, and on top of that was Mission Critical OE. We also had Technical Computing OE, which was primarily there for the Unix workstations. So when we moved to 11IV3, we moved to the latest OEs shown on the right-hand side, and we also included some extra functionality with each one of these OEs. So we start off with a base OE, and then we could either layer on top of that HAOE, which gives you all the service guard functionality, or Virtual Server OE, which gives you all the virtualization capabilities. Now, if you want all of those capabilities bundled together, then you can deploy Data Center OE. So really nice, clear bundling, and we also have e-delivery. So instead of having to receive a physical DVD installed from the DVD, you would download an ISO file from us and use that ISO file or a depot instead of a DVD. So there is a plan, sort of a migration plan for you going forward from the historical OEs to the latest OEs, and there's a little diagram bottom left showing you how that might work. So you can move to a higher OE if you wish to, but there is a cost associated with that. And don't forget, we don't do trade-ins in most of the regions now, so you'll need to speak to your account director or manager to work out how the cost would be planned out with any move forward to a different OE. So if you're on 11IV1 or 11IV2, how might you move forward? So we start off in the middle top of this flowchart here. So you're on sustaining engineering support. Do you want to upgrade from 11IV1 V2 to V3? If you do, great. Upgrade to 11IV3, their update UX or cold installation. Obviously you've got to have application support for that. It's relatively straightforward. Most of the current platforms will support 11IV3. If it's an HP9000 system, it would deploy the PA-RISC binaries, and if it's an Itanium system, then it will deploy the Itanium version of the operating system, of course. So if you don't want to do that upgrade, what choices have you got? You can consolidate your existing OS instances onto newer hardware, or you can stay on the platform that you're running on today. So, as mentioned earlier, we still have support for 11IV2 without sustaining engineering until the end of December 21. Now, if you want to move to new hardware, there's a few options. So, one of the things that we can do relatively easily is to move those operating system instances into containers running on the latest hardware and the latest operating system, HPX 11IV3. We do have Point Next consulting services to help you to do this, so you're not on your own. With some applications, it's relatively straightforward. Some applications won't move at all, but there's usually a little bit of migration work involved with all of those. If you're on an Itanium platform, you can move existing instances of HPX 11IV2 straight into VMs, Integrity Virtual Machines, running on the current platforms. So a virtualized environment with a VM running your existing version of HPX 11IV2 Itanium. So what firmware and hardware enablement is required? Well, when you run Update UX to change the version of your operating system or revision of your operating system, it automatically deploys the hardware enablement bundle, and that will be required for your platform types, for example, i2, i4, or i6. So support of that platform will be dependent on the update level of the operating system. And of course, the best practice is always to install the latest firmware, but the firmware levels required are again documented in the README and release notes for the operating system. So as you can see there, for i2, so Itanium servers running Intel Itanium 9300 series CPUs, you need at least the September 10 release of HPX 11IV3. For i4, you need the September 2012 update version, and for i6, you need the version released last year, the 2017 update release that's will display as 1705 when you run SWList on your server. So that's what will be returned, 1705, on the version required for the i6 servers. So again, you need to check your update level of the operating system using the SWList command as shown on the right-hand side there. And then if you need to update, always do a preview. So I've literally done hundreds and hundreds of these updates on operating systems over the years, and it is pretty straightforward and very robust now. The thing that you need to make sure of is that you have plenty of resources, in particular memory, available to do the update. And the preview will check this for you. So always do a preview as a little check before doing the update itself. And then if you are short of memory, or you need some more resources in other ways, the preview command will tell you this, and it will ensure that you have a nice clean update. You can update from a depot location, from the DVD, or from a remote DVD on an Ignite server. There's some examples on the right-hand side there of the SWList outputs showing you the revision levels again. So let's have a quick look at the virtualization technology. This is really, really helpful when you're doing migrations and consolidation at the same time. So we have HPE ARIES that we've already mentioned. This gives us the binary compatibility across the HP9000 Integrity platforms, HPLUX containers, HP9000 containers that are laid on top of that, and then Integrity Virtual Machines or VPARS version 6. So a quick look at how ARIES works. So here on the left-hand side we have the PA RISC server. We've got the HPLUX 10 or 11 operating system, and the PA RISC application sitting on top. So what we can do is we can take those applications, we can roll them up into a big tarball or copy them from one system to another, or try and run the installer to install them on the Itanium platform. That binary will get interpreted by ARIES and it will run on the Itanium 11IV3 system. So you may have some problems with other related parts of the software, for example the shared libraries, but basically, you know, this will work 9 out of 10 times. Just take the application, move it onto the Itanium platform, and it will run. Or you can recompile the application if you own it, or if the ISV is capable of doing that for you. And of course, then you gain the full benefit of the platform from a performance and support perspective. So typically, if you run PA RISC binaries on an Itanium server, the ISV will not support that. If you compile and then run the native compilation on the platform, it does tend to be supported. So we've got the two options there. So if you were going to try and run your HP9000 application on the Integrity 11IV3 platform, what do you need to do? First of all, you need to identify what you need to move. So quite often, if you try and install your HP9000 application on an Integrity server, the first thing that will happen is the installer will say, I'm sorry, I'm not going to install because you're trying to install me on the wrong platform, and it will abort. So there's two ways around that. You can try and write a short script that tells the application that it is sitting on the right platform and allow it to install or modify it to install. Or you can lift and drop the application onto the new platform. So to do this, you identify all the bits that you need to move, discover any dependencies like shared libraries or other procedures and applications that are required, for example, middleware or web servers. Then you need to roll up all these pieces into some form of transportable package like a tar file or a backup, move them to the Integrity platform, and then unroll that tarball or restore that backup and try running it on the new platform. So how can the virtualization Continuum help you with this move? Well, let's have a quick look at what we have to start with. We've got HPE NPARs. So NPARs are supported on Superdome 2, their isolation of the cell blades and the IOX chassis, or on Integrity i4 and i6 blades. So for example, an 860C has one blade, so it has one NPAR. 870C has two blades, so you can have one or two NPARs. 890C i4 or i6 has four blades, so you can have 1 to 4 NPARs. And that provides really good electrical isolation of the different operating system instances for you to consolidate your workloads on. And then we have the vPARs and Integrity Virtual Machines v6. So this is where we have a hypervisor. The hypervisor is 11IV3, and then we can either create a virtual machine or a vPAR. If we create a vPAR, then it gets dedicated CPU and memory resources, and that resource is taken away from the hypervisor. It's no longer available to the hypervisor. So we have very good performance and obviously isolation of the CPU and memory. Integrity Virtual Machines, on the other hand, allows you to share just about everything. You've got very good sharing of the CPU and memory resources. So it's a very good sharing platform, but doesn't quite have the same performance or the level of isolation as Integrity vPARs. And then we have HPLUX containers. So this is where we use one kernel and basically share the operating system to use that single kernel. So this is the best use of resources that we can possibly get, but the least amount of isolation that we have. And this is one of the key technologies for allowing us to move the HP9000 based applications and operating systems onto the latest platforms. Of course, all of these things can be used in conjunction with each other. So for example, you could run an Integrity Virtual Machine on an NPAR, and inside that Integrity Virtual Machine, you could run HPLUX containers. So let's have a quick look at HP9000 Containers. How does it work? So on the left-hand side, we've got a PA RISC server, and on the right-hand side, we've got the latest Integrity server running HPX 11IV3. Of course, inbuilt into that 11IV3 OS is the ARIES translator. So on the PA RISC server, we've got it installed with, say, HPX 11IV1, and we've got an application running on there, for example, an old version of Oracle. So now what we want to do is to create an image of everything that's on that server. So this is the application and the operating system, everything that's on the server, basically in all the core directories. So we now have our image sitting on the PA RISC server. And now we want to start modifying the Integrity server to accept this ecosystem. So we install HPX Container software, and then on top of that we install the HP9000 Container software. So now we're nearly ready to create a container, but not quite. So first of all, we have to move that image that we've created over onto the Integrity server, and we create a mount point for that, and then we create the HP9000 Container. So this might be a little bit strange doing it this way around, but we have to direct the container to use that existing OS image that's located on a file system on the Integrity server. So it is a little bit unusual doing it this way around, and it can catch you out sometimes, But this is the way that we create HP9000 containerized systems. So now we have an Integrity server. It's running HPX 11i v3 Itanium version, but it can execute this 11i v1 PA-RISC-based operating system and all the applications sitting inside there. It has its own namespace, so it's got its own IP address. You can patch it independently and things like that. So some of the advantages of using HP9000 containers. Put simply, it's a lift and drop move. You back up everything that you've got on your existing server. You prepare your Itanium HPLUX 11i v3 system for it. You move that image over, and then you just run it on that new server. So 99% of the time, that containerized image is just going to run quite happily without any issues on the new server, and you've migrated very easily. So there's not an awful lot of migration work to do. You don't need to work out all the files and directories used by the application. You don't need to try and fully install her into running on a non-native platform. And of course, it's just running on top of all the shared libraries and infrastructure that it always has done on the PA-RISC 9000 system. So one of the real benefits of migrating platform is consolidation. So the HP9000 servers, PA-RISC CPU was great at the time. Now it's outperformed by all the Itanium CPU cores. So what we can do is to consolidate multiple HP9000 systems onto one relatively small Integrity server. So how do we do that? But by maintaining the isolation. Well, we can use a virtualization. So what you can see here on the left-hand side, I've got two separate servers, HP9000 systems, and I can migrate those into Integrity virtual machines running on one Integrity piece of hardware. Now the beauty of this is you've got control of the kernel for each of those instances. So if you've got a 32-bit operating system, you can adjust the kernel parameters to suit that. If you've got a web database, you can adjust the kernel parameters to suit the database. If it's a web server, same with a web server. So you've got this isolation and the capability to manage it as a separate entity, even though it's living on a new server. And you can also move it relatively easily because you've got all the capabilities of move, online move, offline move, and things like that you get with a virtualized environment and a hypervisor infrastructure. And of course, you're now capable of talking to all that new hardware from a storage and networking perspective that connects to the Integrity server, the latest version of the product. So you're no longer tied by the I/O infrastructure that was used for the HP9000 systems. So how do we go about creating an HP9000 container? So on the left-hand side here, we've got an RX 2800, one of my favorite platforms of all time. It's relatively small, 8 core and 16 gig. We install Data Center OE on top. It could be base OE, doesn't have to be Data Center OE. It could be VSE OE as well. We then install the HPX Container software. We then install the HP9000 Container software on top of that, and we have our container. So the important thing here is that you have to create the container after restoring the backup from your source HP9000 system. Once we've completed all this, we can start the container. And we can start and stop it, create it all from a GUI within System Management Homepage. For those who are not familiar with System Management Homepage, this is the tool that replaces HP Systems Insight Manager in some of the older systems and SAM. So this is a GUI for HP9000 container creation. So when we come to the GUI, don't forget we must already have restored our image. So we've created the image on the 9000 system. We've moved it over and put it into a file system on the Integrity server, And now we're ready to create the container. So it's called host 10. We can give it an IP address. It's an HP9000, what we call a system container, which means it has its own namespace, IP address, and things like that. We can give it an amount of resources, so we can use a fair share scheduler and give it a share of the system resources, or we can use psets and give it a number of cores and a percentage of the memory to use. And we can also put other capabilities in place, like get it ready for the Apache web server and things like that. So tool sets are available with HP9000 containers and with HPX containers generally. So once we've created our container, this happens fairly quickly. We can now start it in the GUI, or we can start it on the command line, and then we just log into it and treat it like we would any other server. So as an example on the left-hand side here, we're just starting the Oracle application. So remember, this is an Oracle binaries. It won't be supported natively on the Integrity Itanium HPX server, but it may be out of support with Oracle anyway. And we just run the standard Oracle commands, just as if you were running natively on the HP9000 system. So which platform should you choose? Well, some things dictate what platform you will go to. For example, scalability. You know, if you needed 16 sockets, you'd have to go on to Superdome 2, for example, or you need a lot of I/O or particular I/O connectivity. That will dictate what platform you could go to. So don't forget, we've got the RX 2800, so that's 2 sockets, 16 cores, 384 gigabytes maximum. You can go above that with the blades to 8 sockets, 1.5 terabytes. Anything bigger than that, you need to go to Superdome 2. Or you may just need the RAS and reliability features that are built into Superdome 2. And of course, we have all the utility pricing capabilities with Superdome 2, like ICAP and TICAP. So if you want those sort of features, you need to go to Superdome 2. Some I/O connectivity is only available on certain platforms. So for example, the Integrity blades don't support 16 gig fiber channel mesh cards, whereas the RX 2800 and the Superdome 2 have a stand-up 16 gig fiber channel cards. So the connectivity may also dictate what platform you choose. So CPU sizing. So for general platform-to-platform migration, so this could be 9000 to Integrity or Integrity to a later version of Integrity. I always use the spec-int rate base numbers. I work out what the rate per core is for that spec-int rate base from a public website. And then I just do a straightforward comparison with the source and target platforms. For HP9000 containers, then the administration guide will guide you to use one HP9000 core for one Itanium core. So this is typically very conservative, but if you don't know how your workloads might scale when they move platform, it's just a very safe to be. You can always try a small sample of your workload on the new platform, measure how it runs, get some guidance on what the scaling ratio is, and then use that going forward. So one of the most important things when migrating platform is to consider the amount of memory that you need. So it's fair to say that HPX 11IV3 needs a lot more memory than 11IV2, which needs a lot more memory than 11IV1. So this is not a bad thing at all, because applications need memory, and if they're short of memory, they never tend to run very well. I would always recommend a minimum of 4 GB of RAM for HPX 11IV3 just for the OS instance. So typically, when you boot 11IV3, it will automatically grab 3.5 GB of RAM. So it needs that. Then work out what requirement you need for the applications that you might want to stack on this one OS instance, and then maybe add a little bit more on top of that. If you're using virtualization, you need to add an overhead for this as well. So calculate what the OS and application requirements are. Don't forget that 4 GB, and add a minimum of 10% overhead, and then round up. So for example, the Integrity Virtual Machines Administration Guide will give you exact numbers on how to size this but from my experience, I would say go with a minimum of 10%. So if the number that you calculated is less than that, still add 10% and then round up. So for example, if you've worked out that you need 14 cores for your target platform, then because of the granularity of the CPUs in the latest platform, you would have to deploy 16 cores anyway, because we only have 4-core CPU or 8-core CPU. If 64 gigabytes of memory is required, then make sure you add a little bit more on and maybe take it up to 72 gigabytes. Hypervisors in particular do not like being short of memory, and you will really be impacted if you don't have enough memory for the new platform. So which platform should you go for? So we've already talked about some of the scalability problems, and here I've just put some recommendations together based on what platform you might be running today. I'm not going to talk through all of these, but you can obviously reference these if you like. But just consider RX 2800, 2 sockets maximum, Blades 8 sockets maximum, Superdome 2, 32 sockets maximum, and that resiliency that you just cannot get from the other platforms. So a little bit of platform positioning as well. So the green coloured line is more or less the recommended way to go, and the orange lines give you alternate versions. So this is by no means prescriptive. It's up to you to decide what would be the best platform, how you can consolidate your workloads, and which platform is best for your workload, what RAS features it needs, and what you might be doing with the platform going forward. So all the choices are there. It's just a little bit of positioning just to give you an idea of some of the possibilities available. So should you virtualize the target platform? Well, it does give you the capability to deploy multiple workloads on there, and you have the isolation of the OS instance. So for example, if you wanted to run 2 containers on this target platform, if you put those containers into VMs, then you can start, stop, reboot, upgrade, do anything you want with the container running in that VM, and it will not impact anything else running on that hypervisor. So it does give you a level of flexibility. You can resize as well, of course. It just gives you that management flexibility and capability that frees you up from any limitations of the underlying platform. You do have to consider the licensing implications. You are moving platform, so how many cores are you running now? How many cores will you be running in the future? Is there any difference in licensing on 9000 ARIES cores to Titanium cores? Does the ISV support this new environment? If they don't support it, does it really matter? Is the application still in support from the ISV? Is it already out of support? All these things you need to consider and then make a decision on how you will migrate going forward. So there's just a few examples. So I've put the RX 2800 underlying here in all the examples, but this of course could be Integrity Blades or Superdome 2 instead. It's just easier to draw the RX 2800 on the diagram. So top left, we're going from an HP9000 system. It can be a V1, V2 or V3 pair risk system. We can drop all of those into containers. So we put HPX 11IV3 on the RX 2800, and then we can natively deploy HPX containers, multiple ones of them. Inside there, HP9000 Container software for these particular images, and put those OS images inside HP9000 Containers. Of course, we could also run standard HPX 11IV3 images inside standard HPX containers on the same platform. Or we can generate that extra level of isolation. We can create a VM or VPAR first, and then install the HPX containers and the HP9000 containers inside that one VM. Give that extra level of management flexibility. And of course, control over the resources. So now we control the number of cores available in that VM right down to 0.2 of 1 core in effect. So for Itanium to Itanium move, of course you can update the operating system to run it on the latest platform, or if you're running HPX 11IV2, then you need to create a VM. So remember, HPX 11IV3 is the only HPX version supported natively on the latest version of the servers. So if you want to run HPX 11IV2 Itanium version, you need to create a VM and deploy that operating system within the VM. So again, looking at the options, if we want to go from an HP9000 peer risk system, we can use HP9000 Containers. It's more or less lift and drop. We can use ARIES, so we can try and get the application to install on the Integrity server, or we can roll up all the files we need from the application, copy them over onto the Integrity system, and then run them and fix any issues we have, or best performance, best supportability, best certification, Recompile for the Itanium HPX 11IV3 platform. So the recommended path from HPE is to recompile if at all possible. Of course, this isn't always possible. You might not have the source code to be able to recompile with. The things that you're trying to link against are out of support anyway, or they're not available. So all the things that we've talked about so far give you an option if you can't recompile. So some of the best practices. So we have these two great tools, DRD, Dynamic Root Disk, and Ignite UX. So Ignite UX, it's a really, really powerful tool. It can be a little bit daunting when you come to try to use it in the first place because the admin guide is really long, but you only need 3 or 4 pages out of that actual admin guide to get Ignite UX up and running to a level where you can use it for these types of migrations. So let's have a closer look at these. So Dynamic Root Disk, it's got this great capability to clone the boot disk. So you break the mirror from your existing server for your boot disks, so you've now got a spare disk. You install the DRD software, you tell DRD software to clone that disk, it creates a copy, it's very quick, 15 to 20 minutes. You then tell it to rehost, so it gives this cloned copy a different host name and IP address, and it's ready to boot up and it won't conflict with the operating system that's active and running on the server. If you have a problem, you can simply drop down and reactivate the old image. So one of the things that you can do with this is you can create a clone and then you can run update UX against the clone disk. So you've still got your existing operating system version, revision version there, but you're going to do the update UX on the cloned disk. As long as everything works okay, you can activate the clone and you've now got your updated system with very little downtime, literally just a reboot. So a great capability for creating cloned disks. So Ignite UX, again, it's a great tool. So what we can do is we can roll up the existing server into this big tarball of an image, if you like, a big backup file. But what we can do when we come to redeploy that to use on a cloned system or a migrated system is we can add other things to it. For example, we can run config files against it. We can add more software to it. We can add drivers and things like that. So we can install it, we can tune it, we can create the archive, then use it on the new system and prepare it for support on the new system with the latest drivers and the latest version of the operating system. So a really great and powerful tool. So you're probably familiar with the eval portal. So we have some problems with the eval portal at the moment that we're looking into. But here you can go and get the trial versions of various pieces of software. Fortunately, everything that you need to do the migrations is on the software depot. So this is where you will find the HP9000 software, the HPE Container software. This is what we call a web release. So go here and you will get the latest versions. The software is available on the OE DVDs. So if you've got the OE DVD and you just want to go and have a look at it without downloading anything, you can get the version of the container software released with that particular update release, but it's always best to go onto Software Depot and get the latest version if at all possible, particularly if you intend to use in production. So the great thing is about the current platforms, we've got fantastic longevity on the supportability right through to the end of December 2025. We've still got innovation coming. I've got some news in a few slides about some things happening with NVMe. So we now have the NVMe driver available within HPLUX and support for the P3700 Intel IO accelerator cards, but we've got better to come. So here's some links that you might find useful. In the middle there, we've got the server support matrix. So this is where you'll find the public roadmap that I showed earlier on. And don't forget, you can use Power Advisor now with the latest tools. So this will give you the exact power sizing for your configuration of server, and that is a publicly available tool. So coming next, we've got phase 2 of the NVMe support, and we've got an update webinar coming for that in June. So look out for the links and emails surrounding that. So that's all I have for you now. I'm going to hand back over to Iris, and thanks for your time and for listening. Thank you, Iris.
Dennis, my thanks to you on behalf of myself and our audience today, because you certainly have organized this information very well for us. And I also want to thank the team that's been working with you behind the scenes to answer all of the questions. So we've had a number of questions that have come through, and all of them have been answered, and the answers have been posted, so each and every one of you in the audience should be able to see that. Now, as we do very often, we do want feedback from you. We'd like to know, how did we do today, what else we can do tomorrow, and what other topics around HPLUX and integrity are very important to you. So one of the things that I want to do is push out that survey to you. So hopefully you've unblocked a pop-up, and the pop-up from this event. And let's make sure that we get the URL active and pushed out to you. So a separate tab will pop up in your browser. Just a few questions, and we'd really value that. Before we wrap up for today, I want to go back to Dennis and see if there's anything in particular you'd like to say, sort of to summarize everything, that would be very helpful to our audience.
Yes, thanks, Iris. There's a lot of technology in the slide deck there, but it can be relatively simple, you know, to migrate platforms. So don't think everything is complicated and you have to use virtualization, or you have to do this, or you have to do that. We do have consulting services available to help you from point next. So if something does look complex, there is help out there for you. But we have great platforms going forward, and you know, please ask us to help you with the migrations going forward. Thanks, Iris.
Thank you, Dennis. And I will thank the team of Tuan, Ravi, Mahesh, Vasu, Lori, and Vikas, who have been in the background helping out. You've heard all of those names in the past years, and we're glad to have them with us today. And with that, we're going to wrap up and wish everyone a good morning, a good afternoon, or a good evening, no matter where you happen to be in the world. So thank you.